Okay, the rest of this week we're going to be doing quadratic equations that have real life applications. So these types of equations are going to have a negative a value. They're going to open down. The parabolas are going to be upside down, and then the graphs are going to be in the first quadrant. So it's going to be something that looks like this. It's going to be time is going to be your x-axis, so we're going to measure the height, the y-axis, in feet, depending on how much time. So these types of problems have to do with throwing something in the air, or a rocket shooting in the air, or starting from somewhere up high on top of a building and dropping something off of a building. And it's all about how long does it take for that object to hit the ground. Whether it started on a building and fell down and hit the ground, how long did that take? Or whether it started on the ground or near the ground and was thrown up in the air and then came back down and hit the ground, how long did that take? So I just made up kind of an example here. Let's say you've got a firecracker, a little bottle rocket or something that's on the ground, and you're going to shoot it up in the air. And let's say it goes all the way up to 100 feet. Well, if you're going to graph that, it's not going to be a straight line. Let's say it takes 3 seconds to go up to 100 feet. So that would be the point right there, 3 and 100. After 3 seconds, 1, 2, 3, you're all the way up to 100. You started at 0, 0. It's not going to be a straight line, a consistent speed all the way up to 100, going at a consistent speed and then all of a sudden stop. Right? It's not going to work like that. It's going to take off real fast. It's coming off the ground real fast. And as time goes by, gravity is pulling on it. So it's going slower and slower and slower until it finally gets to as high as it's going to go. And then it slowly starts falling back down. And then it gets faster and faster and faster as gravity's pulling it. So it's symmetrical. It's going to look like a parabola. So here's the numbers I made up. After 0 seconds, you have 0 height. You're on the ground. You light the firecracker. After 1 second, it's all the way up to 50 feet. It took off real fast. After 2 seconds, it's at 80 feet. So in that first second, it went 50 feet. After another second, it only went 30 feet. It's starting to slow down. After the third second, now it's up to 100, so that it only went 20 feet. And that's as high as it goes. So it gets all the way to the top, then it starts falling. So after 1 second of falling, it fell 20 feet. After 2 seconds of falling, it fell 50 feet. Now you're down to 50. And after 3 seconds of falling, it's back to 0. So it's a symmetrical parabola that's upside down that looks like this. Your x-intercepts are 0, 0, and 6, 0, and your vertex, which is a maximum, was way up here at 3 and 100. So that's basically how it works. When something goes up into the air, now there's wind factors and other factors. These are all kind of assuming that it's in a vacuum. But they're all symmetrical. They go up at the same speed that they come back down. They're slow at the top. They're fast by the ground. All right, now there's an equation for this that looks very similar to ax squared plus bx plus c, but we use different letters. We use t squared for time instead of x, because now our x-axis we're measuring with time. And instead of b, we use a v, which is initial velocity. So like that bottle rocket problem, it had a speed coming off the ground. Whatever that speed was, that would go in for your b. This negative 16t squared, that never changes. That represents gravity, and gravity is constant. So every problem that you're going to do in this week with these real life examples is going to start off with negative 16t squared, because that represents gravity. Vt is your initial velocity, and then h stands for height. So in that bottle rocket problem, h would have been 0 because we were starting off on the ground. All right, and we didn't know what v was. So perhaps the numbers were like this. Perhaps the firecracker was going up at 40 feet per second. When you lit that thing, it took off at 40 feet per second. All right, and then the height was 0, then your equation would look like this. Negative 16t squared plus 40t, because 40 was our initial velocity. And then 0, you don't need to write plus 0. There was no height, so you just leave that off. Now, what you're going to be asked to do in the homework problems is figure out how long it takes for it to come back down and hit the ground. When does it hit the ground? Well, look at this graph. When it hits the ground, the height is 0. So this took 6 seconds for it to go all the way up and come back down and hit the ground in this example. So when it hits the ground, that's an X-intercept. So basically these problems are just finding X-intercepts, which we've been doing. So it's a fancy way to say find the X-intercept. Whatever your X-intercept is, that's going to be t instead of x, and that's going to be how long it took, how many seconds. So to solve for X-intercepts in this one, you're going to have to use the quadratic formula. So you'd have negative b, which would be negative 40, plus or minus the square root of 40 squared minus 4 times negative 16 times 0 all over 2 times negative 16. So it would look like that when I substitute into my quadratic formula equation. Well, you can see that with the height being 0, that 4 times negative 16 times 0 is going to be 0. So you're just going to end up with the square root of 40 squared. So you're going to square 40 and then take the square root of it. You're going to be right back at 40. So this is basically negative 40 plus 40 divided by negative 32. Sorry, plus or minus. And in this case, if you do negative 40 plus 40, you get 0. So that would be our 1, this would be 0 over negative 32. So our 1 X-intercept is at 0, 0, which makes sense because in the chart, after 0 seconds, we had 0 height. All right, the other one, negative 40 minus 40, is negative 80. So you'd end up with negative 80 divided by negative 32. And if you use if you divide a negative divided by a negative, you get a positive number. And 80 divided by 32 is about 2.5, a little bit less, probably a little bit more than 2.5. So it takes a little bit more than 2.5 seconds in this example for the firecracker to go all the way up and come all the way back down and hit the ground. So it takes about half that time to get as high as it's going to go. So it took a little over a second to get as high as it was going to go. Then it took a little over a second to come back down and hit the ground. So that's what the problems are like. There's only 3 problems in the homework, but they're all about finding the X-intercept using this formula, which is just different. It's the same formula we've been using. It's nothing new. It's just a little bit different letters, and it can be a little confusing at first, but just think, find the X-intercepts, use the quadratic formula. Now there are examples where it might say something falls off a tree from 50 feet up in the air. All right, well, if it falls off a tree or if something just gets dropped, its initial velocity is 0. Right? It's not being thrown down. It's not being launched. It's just being let go, and it's starting with 0 speed, and gravity is making it accelerate. So if something is just dropped, then v is equal to 0, and then it's a little bit easier to solve. So let's say you've got a tree that's got a piece of fruit on it. That's a tree with fruit on it, if you couldn't tell. And let's say that's 60 feet up in the air, and that piece of fruit just one day falls off to the ground. How long would it take it for that piece of fruit to hit the ground? Well, v is equal to 0, h is equal to 60, so you'd have negative 16t squared plus 60. And you'd have to set that equal to 0 and solve for t squared. So now since we only have 1 t, you don't have to do the quadratic formula. Now you can just solve this like you normally would for x. You could subtract 60 to the other side, divide by negative 16, and that'll be your t squared, and then take the square root of that number. So subtract 60 to the other side, and you get negative 60. Divide by negative 16. Negative 60 divided by negative 16, that's going to be a positive number because a negative divided by a negative. It goes in there almost 4 times. So since I don't want to get a calculator out, I'm going to do myself a favor here. and say that this piece of fruit was actually 64 feet up in the air when it started, because now these numbers will divide real nice. So t squared is equal to 4. Take the square root of that, and t is equal to plus or minus 2. Well, it didn't take negative 2 seconds for it to hit the ground, so we're just interested in the positive 2. So if a piece of fruit falls in a vacuum from 64 feet up in the air, it's going to take exactly 2 seconds to hit the ground. All right, so there's a couple examples. And then Wednesday's homework is the same type of problems. It's just the next 3 problems in the book. So I'll put another video up tomorrow. If you struggle with this off the bat, that's okay. We'll do it again tomorrow, and I think you'll get it. You guys are good.